All right, so to make these new set of videos a lot more relatable, what I'm going to start doing is doing it through the student's perspective. So this is what you guys see when you go into Unit 4, the first module. So let's get into this. All right, let me make sure I'm reading things off. Okay, cool. So let's get into this first module of the new unit. And in this lesson, we're going to learn how to solve rationals and radical equalities. This is, I think, kind of interesting how we're going into this now because we've already kind of gone into this before. But let's get into this. All right, so solving radicals and rationals. So doing this, we're going to look into what we can do to simplify these expressions. So when we're simplifying this one, for example, we're going to have to do some work. So again, this is the warm up. So they're going to start us off with stuff that we should already know how to do. So we have x plus 3 over x plus 4. We can't really simplify that. Minus, we're going to see that we can simplify that by factoring out this 3. So factoring in this case is doing GCF or the opposite of distributive property. We're dividing everything by 3. And then the bottom part over here, so give me a second, still getting used to using these new tools. The next thing we're going to do here is we're going to try to factor this over here. So let me see if I wanted to highlight this. So that part right there. So we can do this by the box method or the X method. I haven't used the X method too much, so I'm going to try to do that right now. So we want to find two numbers that add up to 2, but when we multiply become -8. So I know I definitely have to have a negative number here. So I'm going to try +4 times -2. If I add 4 to -2, I get 2. And when I multiply, I get this. So that tells me that this simplifies into x minus 2, x plus 4. Now let's say if I wanted to do a box method, just for old time's sakes. I honestly prefer the box method, but I realize some of you guys might have been taught this way, so I'm going to try to teach it this way as well. And then how do I get this? Well, I'm going to do -4 times 2. That'll make this -4x, this 2x. If we combine these, we would get that, oops, it's supposed to be a +4, -2. If we combine those, we would get the 2x right here. So that's how we get this x minus 4, or x plus 4, sorry, x minus 2. So this tells me that these cancel out. So because those cancel out, I end up getting this x plus 3 minus 3 on the top. Since now I canceled everything out and the bottoms are the same, we get this right here. And we see that this plus 3 and this -3 cancel. So we're going to end up with the very first one, actually. So we're going to end up with this. All right. And then let me see if I can erase the whole board. Cool. I'm getting used to these new keys. Now I'm going to do this next one over here, which looks very similar to this. Actually, is it the only difference is there's a plus. Well, remember what we did on the last one? We simplified it to be this. So if you guys have this written down, it actually helps out a lot in this case because we simplified this to be x over, because the denominator is the same, x over, not x over, I am so sorry, 3. I'm already kind of jumping ahead. I was jumping ahead to what we had before. 3 over that x plus 4. So the only thing that's changing here is we have the 3 plus 3. So that's going to end up being this x plus 6. So this 3 and this 3 add up together. So we're going to get that x plus 6. So we're going to change this and move it over to this x plus 6 over here. Now again, we're looking at something similar. So these two, notice that this side of the equation has not changed. So that's still that 3x plus 3. This side of the equation hasn't changed. What has changed is the left side. So this is a good reason to have your work written out, because that way we know that all we're changing is this left side. This right side, we're just going to leave it as, oops, I keep putting that x there. Geez. As 3 over x plus 4, and this becomes x plus 3. Over here, this is going to turn into, we're going to do a box method or an x method. Because there's nothing in front of the x squared, x method can be used just fine. We're going to do 7 and a 12. So 3 times 4 gives me that 12. So if I look at this, I'm going to go like, okay, cool. I can do this as x plus 3, x plus 4. So these x plus 3's cancel out. So I'm left with this x plus 4. And this time it really is an x. And then we go to here. And because the denominators are the same, because they're equal to each other, that means that we're just going to be left with this x plus 4 and this x plus 3 on the top. So that means this one goes here, and by default we're going to have this one there. And the reason why it's by default is, see this negative, it's going to be, instead of a plus 3, it's going to be a minus 3. So that's where we get this. So there's a little bit of a review for you guys, and how to use the x method. Let me submit this. Boom. Done. And as always, guys, if you guys are having trouble, make sure you're reading this to get a firm understanding of what you're doing. They're kind of, I don't know what they're doing here. They're using a different method where what they want to do is they want to make this the same, which I found weird because they could have just factored out, but that's Edmentum being Edmentum. Oh, see, they even do the simplification right here, so they did factor it out. So if you guys are ever having trouble with this, make sure to ask me in class. All right. As you may have noticed, the tiles in the lesson is two kinds of equations. It's how rationals and radicals. So this, we're just talking about radicals, and we're going to be adding and subtracting them. And as always, I'm going to skip the videos. You guys can always watch those on your own. So rational equations. Rational equations is this idea of just fractions, basically. And there's an equal sign. An equation means there's an equal sign. Rational means that there's going to be a fraction. Rational expressions do not have an equal sign, essentially the difference. And again, the idea of rational comes with this idea of ratio. So ratio being a fraction. All right. So let's take a look at this. So rational expression. So cross multiplying is a good strategy to do when we have rational equations. This is also known as proportionality, meaning one proportion over another proportion. So let's take a look at this. So if we have this, we can cross multiply, meaning you can see that they're highlighted here, going here. Then we cross multiply, going across. And we can just use Algebra 1 techniques to solve for that x. And we could check it. I usually don't check my work, to be honest with you. As long as you're doing all this stuff, you're golden. You can always plug in your value into x just to make sure that they end up being the same thing. All right, so now we're going to solve this rational expression. So if this one's easy, again, we're just going to cross multiply. So if I'm cross multiplying, what I'm going to do, so to do the orange, I'm going to do 5 parentheses 6 minus x, and then I'm going to make that equal to my green over here, which is 3 parentheses 4 minus x. So this is a good way to kind of show your multiplication, just doing the parentheses. we're going to multiply this across. Let me use a blue to solve this. So 30 minus 5x equals 12 minus 3x. Now what I'm going to do is I don't like having negative numbers, so I'm going to add 5x to both sides. That's going to give me this 30 equals 12 plus 2x. I'm going to get rid of this 12 on both sides. And that's going to end up giving me this, what is it, 20? It's going to give me this 18. So I can end up getting this 2x equals 18, which means that my x, after I divide this 2, ooh, I tried doing that with the mouse. That was not good. If I divide this 2, I end up getting this 9. We get this 9. And they'll show their work right here. Oh, they did it with purple and orange. All right, so let's move on. So now we're going to do with proportions here. And the way we're going to do this is with the least common denominator. So in rational terms, I always call this my LCM. LCM, least common multiple. Least common denominator is referring to this, but when we're, that looks like a -2. It's supposed to be an arrow. That's a terrible arrow. I'm making it worse. There, now it's gone. We're looking for the least common multiple of 3x, 6, and 3x. So obviously, the hard part is how do I get this 3 here? Well, I'm just going to multiply this 6 times x, and I get this 6x. Well, if I multiply 2 times 3x, I also get 6x. And again, we're going to do it over here. So in other words, my LCM, my lowest common denominator in this case, is going to be 6x. Let's see if I can change the hotkeys later for the tools. All right, so again, we're going to find the LCD, it's 6x. So what they're doing here is like, let's just multiply everything by that. Because if we multiply everything by that denominator, what ends up happening is everything cancels out. So they're skipping a few steps here. What's happening is 6x divided by 3x, that ends up being, let's see here, that ends up being 2. 6x divided by 3x, that's 2. We're going to change that to 2. So that's how we get the 4. And then this 6 cancels out with this 6. So we just get this x right here. And then again, we get 2. But 2 times 4 is 8. So that's an easy way to do this. We multiply everything by the lowest common denominator. All right, and then give me a second here. Let me erase all that. Another way of doing this, oh, they're just checking their work. So if you plug in the 4, everything should check out just fine. Let's move on. So now we're going to do this. So if I'm looking at this, what is my LCM of 4x, 4, and x? So that's obviously going to be 4x, right? We're going to do 4x. This is 4 times x, and this is going to be x times the 4. So I'm going to multiply everything here by 4x. Well, the 4x cancels out with the 4x, so we're just left with 1. 4x times this, the 4's cancel out, so I'm just left with x, so I'm left with minus 3x. And if I do 4x times this, the x cancels out with the x here, so I'm left with 4 times 7. This one wasn't as obvious, so I just kind of left it there in parentheses, and it's easy to simplify. You guys could simplify it yourselves. So 4 times 7 is 28. Now what I'm going to do is I'm going to get rid of this. I'm going to subtract the 1, subtract the 1. So I get negative 3x equals 27. And then I'm going to divide by negative 3. A positive divided by a negative So they're different. So they're different. So we're going to get a negative. So x is equal to -9. So then in here, we're just going to put -9. All right. So moving on. All right. So now we're going to do the original equation. So here's our original equation. And we're multiplying everything by that 6x. So this was the one we did before. Also, oh, I forgot about this. There's this thing called erroneous solutions. So here's the thing. Sometimes answers don't work. So we have to check it to make sure. So you do have to check it once we get into these other ones. The reason being is sometimes, let's say if one of your answers is 0, you can't divide by 0. It's impossible. And when you plug it in, you'll see that you can't get it. So again, guys, watch this video. It does help out. If you don't want to, I mean, there's not much I can do, but I do really recommend these videos. They really break down the steps. And you guys can always backtrack. So I know a lot of you complain that you can't move forward, but that's not stopping you from going backwards. In case you're stuck somewhere, it's always a good idea to kind of see this. And this will actually explain more about the extraneous solutions. All right, so here, this one, they're kind of starting to warm us up a little bit to this harder one. Now, there's an option where it says not applicable, so keep that in mind. All right, so we're going to solve for the two different solutions. So if we're looking for the LCDs of x and x minus 3. Now keep in mind, I can't just subtract this by 3. I have to multiply it by something. So what ends up happening here is we kind of just multiply it by each other to make it work. So the LCD in this case, we just multiply by each other. It's the easiest way to do it. It might not be the lowest. And the reason why this works, think of it this way. Let's say we had 2 plus 1 over 3, 1 over 2 plus 1 over 3. You can easily just be like, I'm just going to multiply the top and the bottom by 3. I'm just going to multiply the top and the bottom by 2. That's all you're doing. Now, the beauty of this is in an equation, you can just multiply everything by your denominator to make this easier. So let me show you what I mean here. So in this case, I don't know why I just didn't Alt-Z this. So in this case, what I'm going to do is I'm going to multiply everything by x minus 3. Now the beauty of this is this x cancels out, so I end up getting this 1 times x minus 3. Now if I multiply this side by x times x minus 3, what happens is this x minus 3 cancels out, so I end up being left with this 1x. And if I do multiply this one by x times x minus 3, what happens is this cancels out here, so I'm left with this x minus 2. So after I multiply everything out, I get my x minus 3 plus my x equals x minus 2. One thing I can do here is subtract both sides by x, and this ends up canceling out with this one if I take away that x. And then I'm going to add 3 to both sides. So I end up with x equals 1. So here I end up with x equals 1. And because there's no other solution, it looks like I'm just going to put this not an answer here. And I think the whole purpose of this question was for you to be able to do that not an answer. Another technique that they're doing here is they're multiplying everything by that. I don't know how they got that 3 there, because everything should have canceled out just fine. Oh, I see. I actually goofed on this one, but it worked out. I was supposed to distribute the x. Oh, well, worked out. You can see here what happened. I was supposed to get that x squared, and that x squared would be that -1, so I got really lucky. Not sure why I just ignored that x there. I'm sure we'll have other questions. So here we go. So looking at this one. Now, here's the hard part. Hard, quote unquote, is this looks really hard. So this is where factoring comes into play. So again, this one, it doesn't have a number in front. So I'm just going to use the box method. I have -8 and then 12, 6. So what I'm going to do is 6 times 6 is 12, but if I make them both negative, that just so happens to make it -8 when I add them. And the reason why I tried these right away is odds are they're not going to try to trick you. So if you look at it, this can be replaced with x minus 2, x minus 6 based off of that x we got. And then our other problems that we have to do are this, comma, and then x minus 6. Well, if we're looking for the lowest common multiple, then this has to be the lowest common multiple. I'm just going to take this and multiply by that. I'm going to take this, multiply by that. So that's the lowest common multiple. So let's do this, and this time I'll really, really pay attention here. So I'm going to multiply this. An easy way of doing it is, since I know I'm going to multiply this, I'm just going to multiply the top by x times x minus 6. I'm kind of skipping a step here, but that step, if you think about it, is kind of pointless because you're doing this x minus 2, x minus 6. This x minus 2 cancels out with this x minus 6. And that, or this x minus 2 cancels out with the x minus 2. I said the wrong thing. And then here, I'm going to do this 1 times x minus 2 because I know that x minus 6 is going to cancel out with that x minus 6. So I'm just left with this x minus 2. And the last thing I'm going to do is I'm going to do just 4. The reason being is this is going to cancel out with all of this. So now I can distribute 6. This is plus 1x, so just x, and this is minus 2, and this is equal to 4. And I'm going to want to make this a quadratic, so that's equal to 0. So I'm going to move this 4 over, so I get x squared. I'm going to combine this and this while I'm at it. So I just brought the x down. And then I'm going to do this -8. And this would end up being -4 because I'm bringing that 4 over. So I end up getting this x squared plus x minus 12. I'm going to x method this. So I get -12. I have an x here. So they're 1 apart because when I add them, I should get this 1. I put in x. I was supposed to put a 1. I'm doing the number in front of the x. So, and I want a negative. So I definitely want my positive number. I have a positive and a negative to multiply into this positive, or negative, I'm sorry. So I'm going to do a positive 4 times a negative 3. So I have two answers here. I have x plus 4, x minus 3, and that's going to equal 0. So this tells me I'm using the zero product property. This tells me that x plus 4, if this is equal to 0, it doesn't matter what the other thing is, it's going to equal 0. So that means x has to equal -4. And if I do this here, what's going to happen is I'm going to end up getting this x minus 3 equals 0. So that means x equals 3. So I have two answers, -4 and positive 3. Now, if we look here, something interesting happens. We don't have a 4. Now, why do you think that is? Let's take a look. So it's negative 4 and 3. I'm going to have to remember that because now they're gone. X minus 4 and 3. The reason why this 3 won't work, or the negative 4 won't work, is if we plug it in, we have negative 4 over negative 4 minus 2 plus 1 over negative 4 minus 6 equals 4 over negative 4 squared. So negative 4 times negative 4 is 16. Negative 4 times 8 is plus 32 plus 12. We end up getting this negative 4 over negative 6 plus 1 over negative 10 equals all of that. So what is that? 44. 44 plus 6 is 50. 50 plus 44 plus 50, so this is 60 over 4. So I end up getting this 2/3 minus 1/10 equals 460. So this, if I make it all 60, I should end up getting this 6 over 60 minus, multiply these by 20, I get 40 over 60. That totally doesn't work. So this just won't work overall. So that's why we don't see that answer there. We don't even see a 3. So unless I did something really, really wrong, let's see what happened here. Incorrect. Oh, you know what? They even show the work all right here. How did I get a minus 4 then? So if I'm looking here, the image shows the equation in part A is the incorrect solution. So what happened here? So what they're doing here, I must have done something wrong. I'm going to see what I did. Wow. I just realized what I did. I did a plus 4. So use the graphing tool to answer the question CBD. Okay. Well, I just realized what I did. I thought things were going to cancel out, and they totally didn't. So if I do this, it's negative 8, and this 12. Hopefully you guys are still paying attention because I totally kept going, and this was totally supposed to be negative 6 and negative 2. That changes everything. It does it though? Yeah, it totally does. It totally changes everything. So this stays the same. This x minus 6 stays there. And this is going to be plus 1, x minus 2, and this is equal to 4. No, this should be the same. X squared minus 6x, x minus 2. If anything, this is at least having me do it again. So this is x squared. I'm going to combine those two to make negative 5x, and it's going to be minus 6. Well, this is totally different, but let's do another box method here. And so multiply would be negative 6 and negative 5. So negative 1, negative 6, and positive 1. I want them to add up to negative 5. So I have this x minus 6 and this x plus 1. We're going to split it up like we did. So it's x equals 6, x equals negative 1. So we have this answer. Why does negative 1 not work? Who knows? Let's try this right here. We have 1 over, I'm just going to do the math in my head. So we have negative 1. This one, if we plug in, well, this is supposed to be negative 1 anyway. Oh my gosh. Negative 1. we have -1 over -3, so this is 1/3. And I'm just going to go for that one. Apparently the other one's extraneous, and I wasted enough time solving for the other one. So let's try this again. And obviously the only answer was this one. And what I do wrong now? 2. Well, even they're not going through all of the steps. They're just going through the denominators. What was it asking? Select all the domains. Oh my gosh. I was totally trying to solve this, and it's saying which one of these values can't happen. Because if I plug in a 2 there, that's all we were doing. Wow. All right. So let's take a look here. The images shown below. So images shows below what's going on here. Well, since I've made a lot of mistakes in this one, I guess I'm tired today, guys. I've recorded 3 of these in a row. So we're going to cross those out. That makes sense. That cancels out with this, so that makes sense. We get that. There should just be, okay, that's making sense. We've already done this. Okay. And then here, and we did this part right here. So what's the misstep? 6 minus 3. I don't see what they did wrong. Then again, this might be, so hold on. -6. Those cancel, so that should just be 4. X, that, x squared, -6. That makes sense. -4, that makes sense. -6, -1, that makes sense. We're doing this right here. It should be +6 and -1. I'm guessing what they're doing here is the fact that there are values of x which reload in a 0 denominator. So if we're looking at the 0 denominator, I did like so much work here. The denominator can't be 2. So since the denominator can't be 2, or can't be 6 or 2, 6 cannot be the answer. So in other words, 6 cannot be an answer because it would make the denominator 0, which cannot happen mathematically. I've seen people try to argue this. Um, Several students always do that. We can divide by 0. You can't divide by 0. Dividing by 0 involves making a group. So let's say I said 4 divided by 0. Make a group of 0. I just won't pick anything. Then you can't divide by 0. Exactly. By you saying, I will just not make a group of 0, if you can't, I just won't make a group of 0, then you're admitting you can't divide by 0. All right, so I'm going to submit that now that I know what I'm doing here. And they'll say it right here. We can't have a 0 at the bottom. So I was doing the answers correctly. The only issue was that was not the question they were asking. All right, so find the root of this using the graphing tool. So by using the graphing tool, what we're going to do is you can either click the graphing tool here, or you can always use the graphing tool over here. All right, so I'm going to go here to graph, and I'm going to do a custom relationship to graph this out. So I have a couple of fractions here. I have a fraction plus another fraction, and that's going to be equal to a different fraction. All right, so let's get this going. I'm going to do this x over x minus 2, and I'm going to do this 1 over x minus 6, and I'm going to do this 4 over x squared. Oh, I forget. Edmentum does control up for squares. And then I get minus 8x. And then I'm going to do this plus 12. And I'm going to plot this. What do you mean that doesn't work? That's exactly what you guys wanted me to do. Oh, I see. They wanted to make it y equals. There's no y. You need to have two variables. I should have known this. Plot that. We see that we cannot have a value here. If I look in close enough, we can have a value right there at that 6 or 6. Let me change these. I like the increments being at 1. That's fine. It says it's not appropriate, but I like it being at 1 because you can see that we can't have that 2 here. So that's how come we can't have a 2 as the x value. Is there's a problem right there. All right, so study the graph, blah, blah, blah. Solve. We want to find where y equals 0. So if we find where y equals 0, it's -1, and that's about it. We can't have that 6, so we see that -1, so we're going to do -1. And we kind of proved that over here. They proved it here. It's just that we can't have 6 as an answer because it makes the denominator 0. So I'm going to click that. We're good to go. You can see the graph there. Next one, using the graphing tool to find the roots of quadratic. So we did that. To use the graphing tool, find the zero. So now we're just trying to find the zeros of just this. So I'm just going to create another custom relationship. Y equals x, control up, squared, hit my right arrow, minus 5x plus 6, minus 6. 6. We're going to plot that. If I don't want to look at my black graph, I can just hide the little thing right there. And see my answers are -1 and 6. So I get -1 and 6 because those are where my zeros are. Observe the roots of the equation. So use the graph to determine, replace it 0 for the y, so the input of the equation is that. Observe the answers. Isn't that the answers? 6 and -1. Use the graph solution. Observe the graph and select the roots. Oh! 6 and -1. I totally didn't see that negative. Ugh. Still tired, guys. I'm sorry. Compare the roots of compare the roots. You found the roots of the rational equation in this part. And the roots can be found by deriving this. Describe the connection between them. So compare the roots you found in part C, which you found derived by the quadratic equation in part D. So comparing the roots. Well, they're the same. The only difference is one of them is 6. So basically, what they're doing here is they're taking the formula that we minimized over here and they're using it. So they're the same. So the roots are the same, but the quadratic does not account for the erroneous solution of 6. I think I said I think it's supposed to be extraneous. I've never learned the correct word for this. I'm sorry, guys. The extraneous solution. I think it's supposed to be erroneous. Well, we'll find out right now. Extraneous. Oh, I was right. Extraneous. I just forgot the E. So basically, what's happening here is because we're dealing with a radical, sometimes there's a wrong answer because it would make us divide by 0. All right. And what's the problem here? So I'm going to give myself a 3. I need to learn to read the question. Also need to pay attention when I factor. All right, guys. So I was hoping to do this all in one video, and then I saw how many slides there were here. So I'm gonna finish the other half of this on a different video. So this is just gonna be the part 1 for it, and I'm gonna try to do 2 videos every weekend. So we'll just get this part is gonna be done in 2 parts. All right.